interference. Now, write the definition of it. The interference pattern in which the interference pattern in which the positions of maxima and minima of intensity positions of maxima and minima of intensity of intensity on the observation screen do not change with time is called sustained or permanent interference. Written?
Yes, sir.
Look what happened in case of sustained interference, means the intensity of maxima or minima. Like, means if we talk about YDSC, young double slit experiment, the intensity of every maxima, means whether it is central maxima or secondary maxima, first maxima, or if we talk about first minima or secondary minima, or will have the same intensity. All right.
Yes, sir. Okay.
So that interference pattern is known as sustained interference. Further, you should write condition for sustained interference. Note down conditions for sustained interference.
Yes, sir. Okay.
Now, first, the two sources should be continuously emit. The two sources should continuously emit waves of same frequency or wavelength. The two sources should continuously emit wave frequency or wavelength. Hamza, am I audible to you? Hamza. Next. Next point. The two sources of light should be coherent. Next, I'll make you write just 4 points. If it is asked in an exam, so you'll be able to write. The interfering waves must travel nearly along the same direction. All right.
Okay, sir.
How many points have you written?
Sir, 3 points.
Great. One more. For a better contrast, for a better contrast, between maxima and minima of intensity, the amplitudes of interfering waves should be equal. All right, Nafisha, written.
Sir, the amplitude of interfering waves should be
equal.
Okay, sir.
Okay. Nafisa, I'll ask you some of the questions. What do you mean by coherent sources? What do you mean by coherent sources? What do you mean?
So coherent sources are two sources of light which continuously emit light waves of same frequency, with zero or constant phase difference between them.
What is the difference between constructive interference and destructive interference?
So constructive interference so the amplitude of two waves get added up as the intensity increases or becomes maximum in constructive interference, but in destructive interference, the amplitude of two waves gets subtracted, hence the intensity becomes minimum. Is that it?
What is the okay, correct. In constructive interference, the path difference is a multiple of lambda or lambda by 2. In constructive interference, the path difference between the two waves is a multiple of lambda or lambda by 2.
Say lambda.
Great.
Lambda by 2. Yeah, lambda.
Just let me know the formula of fringe width. Nafisa?
Yes, sir.
Whatever you know,
Fringe width
you
is,
make mistake, I'll make
the fringe width is d lambda by d.
beta equals to d lambda over d. All right.
Yeah, beta is equal to d lambda by d.
Look, if I immersed a YDSC apparatus in any medium having refractive index mu, how does the fringe width get affected? And how does the fringe width get affected?
Beta will be divided by mu.
Okay. It will increase or decrease?
So it would decrease.
All right. Because the wavelength decreases.
Yeah. Yes, sir.
Okay. What do you mean by monochromatic? Monochromatic means single color. All right, Nafisha. Hamza, am I audible to you? Hamza, am I audible to you? Hamza, am I audible to you?
Yes, sir, you're audible.
How much do you know wave optics? Nafisha, draw this graph. But first of all, let me draw.
Okay, sir.
make of equal width. All right.
Yes, sir. Okay.
This is central bright. This is first bright. Then this is second bright. This is also first bright. This is second bright. This is first dark. This is second dark. This is third dark. This is first dark. This is second dark. All right, this is intensity curve for YDSC. It usually asks in exams. D lambda over 2D is the distance from the central bright, and 3 lambda D over 2D is the distance of dark from the central bright. Fine. Likewise, and D lambda over 2D. These are the cases above the central bright. These are the cases below the central bright. All right, Nafisha. Hamza.
Yes, sir.
Nafisa, if you take difference between these two distances, you will get the fringe width. Isn't it? 3 lambda D over 2D minus D lambda over 2D. You will get D
Yes,
lambda
sir.
over D.
Okay.
Done.
Yes, sir.
Hamza, are you done? Hamza, are you done?
Yes, sir.
Nafisa, did you get it? Hamza, did you get it?
Yes, sir. Understood.
Shall I rub?
Okay, sir. Yeah.
Just remember one thing. According to the wave theory, intensity is directly proportional to the amplitude square. Now this is the formula for the ratio. The topic is comparison. Sorry. Maxima and minima. All right. So intensity max over I minimum equals to R1 plus 1 over R1 minus 1 square, where R1 equals to the ratios of the amplitude of the two waves. Note down, then we will discuss the question.
Yes, we finish.
Next, Hamza. Hamza done.
Done.
Okay. Note down. W1 over W2 equals to I1 over I2 equals to A1 square over A2 square equals to R square. These are widths. All right. Slits. Just remember one thing. Intensity is directly proportional to the width. If I increase the slit width, so intensity will increase. All right.
Okay, sir.
Note down.
Yes, sir, done.
Now, write a question. We will discuss questions on this topic. What is the ratio of the slit widths? What is the ratio of the slit widths? What is the ratio of the slit widths if the amplitudes of the light waves from them, have a ratio 2:1?
Sir, have no
I have
from them having a ratio of 2:1.
yeah. Now we have to calculate the ratio of the slate widths. Fast. Done.
Yes, sir. Answers 2/1. So two.
Yeah.
So it's the same. 2. Yeah. 2:1.
So Hamza, have you done? Hamza, have you done? How did you do this question? Nafisa, how did you do this question?
Sir, I used the same method. The width slits one. So W1 is equal to W1 by W2 is equivalent to I2 by I2 is equivalent to like that. And then I
A1,
canceled the 2 of
A1 over A2
the
is given
roots.
2:1.
Yeah, I know that. Yes, sir. And then I canceled the 2 and then the root becomes 2/1.
Now next question. Right. Two coherent sources have intensities. Two coherent sources have intensities in the ratio 25:16. Two coherent sources have intensities in the ratio 25:16. Find the ratio of the intensities of maxima to the minima. Find the ratio of the intensities of maxima to the minima after interference of light occurs. After interference of light occurs.
Sir, after interference of light?
Occurs
Okay.
first. Hamza, am I audible to you? Picture done.
No, sir, still doing.
Are you getting how to do this? Or shall I make you do for you? Look how to do. The ratio is given 25:16. R1O, this term, two current sources have the intensities. All right. Now what is given? So I1 over I2 is given. That is 25:16.
25/16. Yeah.
Fine. Now we have to calculate the ratio of intensities maxima to minima. What was the formula? R plus 1 over R minus 1 whole
Yeah.
square.
Over.
And
Yeah.
how do we calculate? What is R? Under root I1 over I2. Now substitute the value. 25 over 16, 5 over 3. All right.
Okay. Yes, sir.
Now solve and let me know the answer first. Hamza, also you should respond. Hamza, if you don't get it, please let me know. Hamza, you should.
Sir, I understood.
Now let me know the answer. At least you should respond. What's the problem? If you are not getting, please let me know. Then definitely I'll explain it again. Let me know the answer first.
So it will be 2 by 1.3.
81:1.
How did that?
Okay. First of all, we have to take the sorry. The answer is this is 4. Sorry. I made a mistake. Sorry.
Okay,
All right.
sir.
So
Okay.
9 over 4 and 1 over 4. All right. Square 4 will cancel out.
Okay. Yeah. Understood. Yes, okay, sir.
And
Sir, can I write this first? I'll write it first.
okay.
Yes, sir, done.
Done. Now write the next question. The ratio of intensities at minima the ratio of the intensities and minima to the maxima. The ratio of the intensities at minima to the maxima in YDSC experiment is 9:25. Fine. Now we have to calculate the ratio of the widths. Last question. I just come in a minute. Please do it. Done. Done, Nafisa.
I'm doing it, sir.
Shall I do for you?
Okay, sir.
Now what is given? The ratio of maximum intensity to minimum. Sorry, minima to maximum.
Minima to maxima, yeah.
Nine over 25. What is, we have to calculate the width. What is width?
W1 by root W2.
By this
Yes,
we
sir.
can also calculate it.
Yeah.
So I minima over I maxima equals to R plus 1, R minus 1 whole square. So 9 over 25 equals to R plus 1, R minus 1 whole square. Now we have to take the square root. So it will come out 3 over 5, R plus 1 over R minus 1. Is it okay? Okay, Nafisa? Do you have yes?
No, sir. Yeah, it's okay.
So 3 over 5 equals to R plus 1, R minus 1. You have to multiply. 3R minus 3, 5R plus 5 equals to 2R equals to just check the calculation 3 over 5. Okay, I made a mistake, I think, in the formula. Sorry. it would be minus plus minus plus. So
Okay,
minus
sir.
plus. By mistake, I took wrong ratio. Now further, three r plus 1, 5 r.
Sir, that 2 has to be 3 by 5 is equivalent to r minus 1 by r plus 2 plus 1, right?
What?
The one beside 3 by 5. 3 by
Equal.
5 is equivalent to r minus 1
This is
by
minus.
r plus.
Now further, you have to do the cross multiplication. All right. Now solve further. So 5r minus 3r equals to 8. All right. So 2r equals to 8 and r equals to 4. Okay. So 16.
Okay, sir.
It means W1 over W2 equals to 16 is to 1. Fast. Note down. Then we will start diffraction.
Yes, sir. Okay.
Done.
Yes, sir.
Now next topic. Nafisha, do you have any doubt till now? Nafisha, do you have any doubt?
No, sir.
Okay, fine. Everything is crystal clear.
Yes, sir. If I have doubts, I'll ask.
Note next topic, diffraction of light. Written. Now diffraction. Basically, light travels in a straight line. Light travels in a straight line. Do you know, Nafisha? Light travels in a straight line.
Yes.
Fine. But when a light passes through a small hole, when there is a certain amount of spreading of light on the screen.
Yes, sir.
Similarly, when a light passes by an obstacle, it appears to bend round the edges of the obstacle. Just sorry. So if it is a hole, the light spreads out on the screen. And if there is an obstacle, it appears to bend the round edges. For example, let it be a building. If a light projects on this building, you will find the shadow of this building will be less than its actual length. All right.
Okay, sir.
That bending of light is known as diffraction.
Diffraction. Okay.
Now, write down the definition. The phenomenon of bending of light. The phenomenon of bending of light the phenomenon of bending of light around the corners of small obstacles. The phenomenon of bending of light around the corners of small obstacles or apertures its consequent spreading into the regions of geometrical shadow written. Nafisa, are you writing?
Yes, sir, I'm writing.
The phenomenon of bending of light around the corners of small obstacles or aperture and its consequent spreading into the regions of geometrical shadow is called diffraction of light.
Sir, can you say it again? Phenomenon of bending of light around corners of small obstacles or apertures
And its
is
consequent and its consequent spreading into
Oh,
the regions of geometrical shadow is called diffraction of light.
okay. Yes, sir.
So I'm going to draw two figures. And as the light passes through this aperture, it bends like this. And if it passes through, it bends around the edges like that. All right, Nafisha, this is known as diffraction.
Yes, sir, okay.
Means one more. This is the case of diffraction around the corners. A small aperture, and second, a small obstacle. This is green. This is also draw, Nafisha.
Yes, sir, I'm drawing. Yes, you're done.
Nafisa, let me tell you, means what is diffraction basically. For example, if you let it be two rooms, if I speak one of the room and you are in second room, so will you be able to hear me? Surely.
Yes.
But if I switch on the light in this room, would you be able to, means the light doesn't go in that room, isn't it?
Yes, yes, sir.
Actually, what happens in case of sounds, the wavelength of sound is much bigger than the wavelength of the light.
Yes, okay.
That's why sound diffracts more. All right.
Yes, sir, okay.
Now write down the condition. Just remember one thing. For diffraction, the size of aperture is approximately to the wavelength. So the wavelength of the light is much smaller than the size of the object around us. So the diffraction of light is not easily seen. But sound waves have larger wavelength. They get easily diffracted. Fine, by the object around us.
Yes, sir. Okay.
Hold a minute. Let me draw the figure. Draw this. Nafisha, draw.
Yes, sir. Okay, drawing.